Now let us discuss 1.156. So let us draw the diagram and then we will explain what this question says. Now if you have drawn the diagram, we can see, so let us say this question says there is a buggy of mass capital M, and at the one end of the buggy there is two men, they are standing at one edge, and the mass of each man is a small m. Initially the system is in the rest, this is kept on a horizontal track, horizontal rail, and between horizontal rail and the wheel of this train buggy there is no friction, so mu is equals to 0. So in this case I can say in the horizontal direction there is no force that is going to act, so momentum will remain conserved whenever I need. Now the question says this man wants to jump off. Why they want, I don't know exactly, maybe they want to do suicide or something. So these two men are basically jumping in this direction with a speed u, and the speed u is given, that is the jumping speed, with respect to the buggy. So this man jumps with respect to the buggy with speed u, this man also jumps with respect to the buggy with speed u. Now there are two ways of jumping. Both men can jump simultaneously, or both men can jump one after the other. That is, one jumps and then other thinks, oh my god, I have to also jump, then he jumps. Or maybe in the other process both jumps at the same point of time, both decides now we have to jump now. So both jumps at the same time. So the first part of the question says when both jumps at the same time, what is the velocity of the buggy that will be after the jumping? So you have to find, so first part, velocity of buggy after the jumping if they do simultaneously. So if they jump simultaneously, this is the situation. I'll draw this one and then we'll discuss. This is my positive x-axis direction I have taken. Okay, so let us see, this man jumps and this man also jumps, both the speeds is u in the horizontal direction. Of course the speed u is in the horizontal direction, so this man jumps with the speed u, this man also, but this u is given with respect to the buggy. Now buggy will not remain in the rest when this man jumps, buggy will acquire a velocity u. Why this is so? Because this man when jump, it will press this buggy in the backward direction, so this is pressing the buggy in the backward direction. So if you press the buggy in the backward direction, buggy will acquire a velocity in the backward direction. So let us say acquired velocity by buggy in the backward direction is v1, and the man jumps in the forward direction with respect to u. So with respect to u, so now I can find velocity of man with respect to ground. This is given by this expression. So let us say, I can say velocity of man with respect to ground is equals to, first listen, velocity of man with respect to buggy plus velocity of buggy with respect to ground. Man is going in the positive side with the speed u, buggy is going in the negative side with the speed v1, so minus v1. So we will have u minus v1. Are you getting? Let us copy this one. You can get the same velocity just by drawing a velocity diagram. So this man has two velocity. In this direction the speed is u. In the opposite direction it has a speed v1. So the actual velocity with respect to ground is u minus v1. Now we will apply the momentum conservation. So before you have this, before initial momentum was 0 because there is nothing that is going in the forward direction or backward direction, everything is rest. So initial momentum I can say is 0. Now final momentum, so this is my buggy. This buggy is going in the backward direction with the speed v1, and now these two men are in the air and they are going with a speed u. So each is going in this horizontal direction with a speed u. So what is the final momentum? So momentum of this person is m into u. This person also has a momentum m into u. This buggy has a momentum minus m times v1, and this is equals to 0. From here I can write v1. Let us plug the value of u. U is nothing but v1, velocity of man with respect to ground, that is v1, velocity of man with respect to ground. So basically I have to plug here velocity of man with respect to ground, not u1. So let us say u, and I would have to write velocity of man with respect to ground. So this will not written as u. So let us call this as u1. That is velocity of man with respect to ground is u1. So u1 is velocity of man with respect to ground, because this is given with respect to buggy. So u1 is the velocity of man with respect to ground. So we will have, let us plug 2m, and what is the value of u1? u1 is u minus v1. So this is u minus v1 minus m times v1. This is equals to 0. Are you getting? And if I solve for v1, so we will have 2mu is equals to v1 2m plus m. So v1 is 2mu divided by 2m plus capital M. Are you getting? So in this case, important point you have, that is that this is the mu1, the velocity of a speed of man with respect to ground I have to take. Are you getting or not? So this is given with respect to buggy, I have to take with respect to ground. So let us plug here u1 so that there will be no confusion. So this is the velocity of man with respect to ground, velocity of man with respect to ground. So total momentum will be mu1 plus mu1 minus mv1. This is equals to 0. I think all of you are able to understand this one. Because in momentum conservation you have to take the actual velocity with respect to ground. You cannot take velocity with respect to buggy. You have to take velocity with respect to ground. That's why if I am taking the velocity of man with respect to ground, velocity of buggy with respect to ground, I will have this expression. Now second part says, if both man jumps one after other. So this time they are not jumping simultaneously. So let us say what happens if they jump one after other. So we have jumping one after other. So let us say part B, and they are jumping one after other. So one after other. So this time again you can apply the momentum conservation law and you can solve these equations. So you see initially this is the buggy. Initial momentum of buggy is 0. Now this man, one man remains on the buggy, another man is in the air, and this is going with a speed u with respect to buggy. This question says jumping the speed is u with respect to buggy. Are you getting? Now let us say again, this time this buggy is going in the backward direction of speed v1. Are you getting? So this buggy is going with respect to v1. So what is the speed of man with respect to ground? So this is u, this is v1, so this is u minus v1. So now I can say velocity of buggy is in this direction v1, and the velocity of man in this direction, actual velocity, that is u minus v1. You can understand now. There is no point of doing all this. So this is going with the speed u. This also has a, when this jumps, this has a speed in this direction with v1, so u minus v1. And there is one person that is still in the buggy. So what is the final momentum you have? You have momentum this m plus m, that is the man plus buggy. One man is inside the buggy in this negative direction, so minus v1, and this is in this direction, so m into u minus v1, and this is equals to 0. So I can solve for V1. So what you will have? So you will have 2m. So minus m plus 2m V1 is equals to mu. I have to take this plus also. You can do yourself. This is simple calculation. So V1 will be mu divided by m plus 2m. Now what will happen next? Next man jumps. So initially, now I have the initial situation is this. This man is here and this buggy and the mass m and going in the backward direction with speed v1. Now this man again jumps in the forward direction with speed u relative to the buggy. So this is with respect to buggy. So this is the situation. What will happen if this man jumps? The velocity of this will change. So let us say this goes back with the speed v2. So this is going in the backward direction with the speed v2 and the man is here and the speed of the man is u, but with respect to buggy, and buggy itself is going in the backward direction with the speed u. So the actual velocity of man is u minus v2. Now I will apply the momentum conservation. Initial momentum, what is the initial momentum we have? This man plus this buggy system is going in the backward direction with the speed u v1. So I have m plus m v1 because it's going in the backward direction, that's why I have taken minus sign. Let us say final momentum we have. So this buggy is going in the backward direction with the speed v2 and this system is going in this direction u minus v2. So what is the final momentum I have? The buggy is going in the backward direction with the speed v2, so this is minus mv2. This is going in the forward direction with the speed u minus v2. So this is the final momentum. Now I can equate because there is no horizontal force acting. So m plus m into v1 with a minus sign. This is equals to minus mv2 plus mu minus mv2. Now mv2 if I take common, so I will have m plus m v1, and if I cancel the minus sign, I am doing it in one step. I think you can understand. M plus m v2 minus mu. So v2 will be simply v1. This will be divided. So v1 plus, and this goes this side. So m by m plus m into u. Now if you plug the value of v1, because v1 is the velocity after step 1, this we have already found. So let us say v1 is, so you see in the back your copy you can see. So this is the v1, 2mu divided by 2m plus capital M. So v1 is, if I plug the value of v1, so I will have v2 is equals to v1, that is 2mu divided by 2m plus capital M. This is v1 plus m by m plus u, m plus m into u. Are you getting? So I can do this calculation. So v2 is 2m plus m into m plus m, and I will have here 2m into m plus m and plus m into 2 a small m plus capital M, and this multiplied by u. Are you getting? So this is the final velocities. Let us do some more massaging of the equations. So we will have, so 2m into m, and here you will have mm, so you will have 3m into m. You can do yourself. So 2m into m, and here you will have 2m into m, so 3m. Now 2m into m, so this is 2m square, and this will be, m square. Here you will have, so this is 2m into m, 2m square. Here we will have 2m into 2m, so 4m square. Are you getting or not? Basically we have done one mistake. This v1 in this case is this, I think here. This is the v1. Are you getting this? We have taken basically the back v1, that is not the correct. So this is the v1, mu divided by m plus 2m. Are you getting also? This is the v1, mu divided by m plus 2m. So I have to plug this value here. So v1 is So V2 is V1 plus, you see V2 is V1 plus M by M plus U. So V1, so you have to plug the value of V1 is MU divided by M plus 2M. So this will be MU divided by M plus 2M. So there will be node 2 here. Are you getting? And here also you will have node 2. So this goes here. So there will be node 2 here. So if there is node 2, so let us do again, I think. Or if you want, you can do here itself. So M into M plus M into M. So you will have 2M into M. Are you getting out? So this is M into M. And this is M into M. So you will have 2M into M. Now M square here you will have. And here you will have 2M square. Are you getting? And this divided by 2M plus M into M plus M. So what we will have, so this is to U, so V2 will be, so you will have 2mm 3m square, so 2m square plus m square, so 2m plus 3m into a small m divided by m plus m into 2m plus m into U. This is the final velocity after jump 2. If you see the final velocity after jump 1, so let us say V2, final velocity after jump 1, 2, that this both are jumping one after the other. So final velocity after jump, this is given by 2m plus 3m into m, this divided by m plus m into 2m plus m into U. Now the question also says how much time this velocity is greater than if they jump simultaneously. So if they jump simultaneously, you have a speed of this. Are you getting? So in the case of simultaneous jump, the speed V1 is given by 2mu into 2m plus m. So we have to find what is the ratio of V2 by V1, that is given in the problem. You have to find what is the ratio of V2 by V1. So if I find this ratio, so I will have 2m plus 3m into m into U, and this divided by m plus m into 2m plus capital M, and this multiplied by this is small 2mu in the denominator, and 2m plus m, that is 2 a small m plus capital M will go into the numerator. So you see, you can do your own calculation. So this goes, mu also goes, so you will have simply 2m plus m, and you will have 2m plus, let us write 3m as 2m plus m. By writing this, you can understand soon. And this is 2 into m, so 2m plus 2m. Now I can write this as 2m plus 2m divided by 2m plus 2m, that is 1 plus m by 2m plus 2m. And this is basically greater than 1 because these numbers are positive number. So you will have in this case, so you can say in this case, velocity 2 is, V2 is V1 is greater than 1. So this applies, V2 is basically greater than V1. This means if they jump one after the other, buggy will acquire more velocity rather than jumping the two persons simultaneously. So this result you can remember. If the two persons jump simultaneously, that will not give more velocity to the buggy. If the person jumps one after the other, buggy will acquire higher velocity. This problem can be generalized for n number of persons. So if you have on one side of the buggy you have n number of persons that is just standing, and these persons decide to do suicide one after the other. So one person thinks this whole world has no meaning, so he jumps. And after some time the other person also realizes, oh my God, I have to also do the same thing because this whole world has no meaning for me also. So this goes the process, and people just jump one after the other. That will give more velocity to the buggy. If the all person decide simultaneously that we have to go for suicide, in that case the buggy will acquire lower velocity. Are you getting? So if you have a buggy, if you want to, so let us say one class of person decides to give more velocity to the buggy, that is the maximum velocity to the buggy. In that case, you have to jump one after the other. You don't have to jump simultaneously. Are you getting? So this is a quite good problem. You can generalize this formulation for n number of person. You can do this your own and you see what kind of result you are getting. So you jump, so write down the velocity after fast jump. When write down the velocity when the second person jumps. When find out the velocity when third person jumps. And then you see what are the thing that is same kind of repetition you are getting in the final result. If you find what is the repetition in the final result after doing 3 calculation, you can generalize your result. So you do your 3 calculation at home. Take it as a task. Please do this one. Do the 3 times calculation and then generalize the final result. And the first case, in this case, the first when they all jump simultaneously, that's very simple. In that case, you will have in place of 2, you will have n. So nmu divided by nm plus m. That is very simple. In that case, you will have simply 2 is replaced by capital N. In that case, in the second case, you have to do some manipulation. So let us discuss the next problem.